Hello friends, in this video we are going to study about the various types of capacitive transducers which are based on the principle of change in the distance between the plates, and this principle is used for the measurement of different physical quantities. So let us start with our topic. So capacitive transducers, they are the devices which convert a physical quantity into an electrical quantity, and they are used for measuring the physical quantities by measuring the change in the capacitance. Now, if we define the term capacitance for a parallel plate capacitor, it is given by the relation C equals to epsilon A by B, where epsilon is the permittivity of the medium, A is the overlapping area of plate, and D is the distance between the plates. So you can see that the capacitance, it is dependent upon three variables: epsilon, that is permittivity, A overlapping area, and D the distance between the plates. It is directly proportional to the permittivity and the overlapping area, and inversely proportional to the distance between the plates. Now, by any means, if we are changing any of these three variables, then capacitance will be changed. So we can use this principle in the capacitive transducer for the measurement of the quantities like displacement, pressure, and flow, force, level, and torque. All these physical quantities can be measured by changing the capacitance, and the capacitance will be changed by changing any of these three variables like change in the overlapping area, change in the distance between the plates, and change in the relative permittivity which is caused due to the variation in the dielectric constant. Dielectric constant, or we can say the dielectric medium, it is the medium between the two plates of the capacitor. So if we are changing the dielectric medium, we are changing the permittivity of the medium, and hence the capacitance is changed. So if any of these three changes are done, then capacitance will change and we can measure the physical quantity. So here we are going to study about the capacitive transducers which are using the change in the distance between the plates. Means that in those capacitive transducers, we are changing the distance, that is D, between the plates. Now capacitance and distance, they are inversely proportional to each other, so there will be a non-linear relationship between them. So first here we will see the capacitive transducer which is used for measuring the displacement by using the change in the distance between the plates. Now in these capacitive transducer where we are changing the distance, in the transducer we will have two plates. One will be the fixed plate and second will be the movable plate. Now the displacement which we want to measure, that will be applied to the movable plate. So here in this diagram, you can see we are having two capacitors which are in circular in shape. These the distance between the two plates. One plate is fixed and another is the moving plate. The displacement which we want to measure, that is applied to the moving plate. So when this is displaced, this moving plate is displayed in this direction, means in the right hand side direction, the distance is increasing. As the distance is increasing, the capacitance is going to decrease, because there is an inverse relationship between the two. And when this moving plate, it is moved in the left hand side direction, the distance is decreased between the two plates. So as the distance decreases, capacitance increases. So in this left direction, the capacitance is going to increase. In the right direction, capacitance is going to decrease. Okay. So as we have defined the capacitance as C equals to epsilon A by D. Okay. So here if we see the sensitivity, where our output is the capacitance and input is the D, the distance between the two plates. So here it will be epsilon A by X square. X is the displacement which we have applied on the moving plate. Okay, because we are changing the distance here, capacitance is inversely proportional to the distance. Also from this equation you can see that the sensitivity, it is not constant. It varies with the range of the transducers. Okay, so sensitivity is not constant. It means that the transducer, it is exhibiting as a non-linear characteristic. There is a non-linear relationship between the capacitance and the displacement. If we see the graph for this, so you can see that between X and C we are having the non-linear relationship, and this relationship is, you can see, it is hyperbolic in nature. So due to this non-linear relationship, the transducer is going to exhibit the non-linear characteristic. So this relationship is hyperbolic in nature, but for a small range of displacement, this relationship can be linear. So we can say that this type of capacitive transducer, they are used for very small displacement measurements, because for only a small range of the transducer, there will be a linear relationship between the distance and the capacitance. Now this non-linear relationship, it can be linearly approximated by using a thin film of uh, mica, which is having a very high dielectric constant, and we can make the relationship between distance and capacitance as linear for a small range. So by using a dielectric material like mica, which is having very high dielectric constant, the linearity can be obtained in this type of capacitive transducers. So these are the transducers. This type of transducer, it is used for the measurement of displacement of very small value. Now let's see another arrangement of the parallel plates which are used for the measurement of the displacement. So in this type of transducers, capacitive transducers, we are measuring the linear displacement. Here the displacement which we want to measure, it is applied to a cantilever type of cantilever spring type of plate. Okay, these are the plates. Now when the displacement, when this cantilever spring type of plate is moved, the second plate, means when it is moved here, it is going to again come back towards this fixed plate. Okay, so when the distance is increased, it is coming back towards this. When displacement is applied to this, the plate is again coming back towards the fixed plate. So distance is decreasing. Okay, distance is decreasing means the capacitance is being increased. Okay, now this here we can measure the output, and this is the dielectric medium. So this is also an arrangement which is used for the measurement of linear displacement, whereas the displacement is provided to this cantilever spring type of plate. So distance is decreased and capacitance is increased. So in this type of capacitive transducers, we are using, and displacement is applied when this cantilever type spring plate is moved. So when this is moved, it is going to again come back towards the second plate, decreasing the distance and increasing the capacitance. So in this way, displacement can be measured through it. Another type of capacitive transducer which is using the principle of change in the distance between the plates, it is used for the measurement of pressure, and it is using two quartz diaphragms there, and diaphragms, it is the primary element which is used for the measurement of pressure. So instead of using the plates, we are using the two diaphragms. Okay, so when these diaphragms, they are, means when pressure is applied, the diaphragms, they are going to get elongated. Okay, the pressure will be increased, so they are going to change their shape, and due to their change in the shape, the distance between the two diaphragms will be changed. So in this type of arrangement, we are using two silvered quartz diaphragms. Diaphragm, it is the primary sensing element for the pressure. They are used for generally measuring the pressure. When pressure is applied, the diaphragm changes its shape. So when it is they are in their relaxed position, means when the pressure is no pressure is applied, vacuum condition is being obtained, so they are in their flat conditions. So at that time distance will be different. Suppose there the distance is d. Now as soon as the pressure is increased between these diaphragms, they are going to get elongated, means their shape is going to change. Now due to their change in the shape or the elongation, the distance between the two plates is going to change. Earlier it was d, now it will be reduced. So due to the decrease in the distance between the plates, the capacitance is going to increase, and due to the change in the capacitance, we are measuring the change in the pressure. So this type of capacitor can be used for the measurement of pressure by measuring the change in the capacitance due to the change in the distance between the plates. So here the displacement can of the diaphragm, it varies with the capacitance. How? And also this type of capacitor, this type of transducer is used for the pressure measurement. First, a perfect vacuum is maintained between the diaphragms. After that, some pressure will be applied so that we can use this transducer for measuring the absolute pressure of the surrounding medium. So in this way, we are using this type of capacitive transducers not only for the measurement of displacement but also for the measurement of the pressure. Okay. Now here we have seen that the capacitive transducers, they can not only measure the linear displacement but also the rotary displacement can also be, or rotational displacement can also be measured. So for the rotational displacement, let's see the diagram that how the capacitive transducer which are using the change in the distance between the plates, they can be used for the measurement of rotational displacement. So for the rotational displacement, it can be measured with the help of this type of arrangement. Here we are having a stator and a rotor, and these are the two plates. So when they are moving over each other, the distance between the plates is changing, and due to that, the change in the capacitance is occurs. Now when these plates they are So as the rotor plates of the capacitor, they are displaced in the clockwise direction. When they are moving in the clockwise direction, the capacitance increases due to the change in the distance between the plates. So here the change in the capacitance is used for measuring the angular displacement, and this type of capacitor transducer, it can be used for the measurement of the torque, because due to the torque, the stator and the rotor, they are moving. So the torque, changes in the torque can cause the changes in the capacitance due to change in the distance between the plates. So you can see that the capacitive transducer, they are not only measuring linear but also the rotational displacement. Now there is also a differential arrangement in the capacitor which is used for the measurement of the linear displacement. Let us see the diagram for this differential arrangement. Now when this movable plate, it is exactly in the middle of these two plates, so the capacitance which is linked with these two capacitors, because there will be two capacitor, one will be this and one will be this, okay, so the value of the capacitance will be same. Now if we are measuring an output voltage across this, so capacitance value for this capacitor will be C1 and voltage will be even, and for this the capacitance value will be C2 and output voltage is E2. So when this plate is exactly in middle, then E1 and E2 will be equal, okay, and the distance between the two plates is suppose D, and here also it is D. Now when this movable plate is moved, by a displacement x, okay, so when it is moved in this, so distance will be decreased, new distance will be d minus x, and this will be d plus x. So the value of capacitance linked with each of these capacitor will be changed. C1 and C2 are changed, and also E1 and E2 will be changed. So the output voltage, which is the difference between the two voltages E2 and E1, that is E2 minus E1, that will be changed. Earlier, when E1 and E2 are equal, the output voltage is 0. And when this movable plate is moved, a displacement is applied to it, so new value of the output voltage will be E2 minus E1. So let's see that how this output voltage is used for the measurement of the displacement by changing the distance between the plates by this type of arrangement. Now, from this type of arrangement, we are getting the output voltage which is a difference. That is why it is called a differential arrangement. Okay. Now the value of C1 will be epsilon A by D, and C2 is also epsilon A by D. Okay, because the movable plate, it is exactly in middle between the two fixed plates. Now output voltage, the output voltage from the first capacitor E1 will be equals to E2, and it will be E by 2. So if you are getting the output voltage, which is the difference between E2 and E1, it will be 0. Now when the movable plate is moved, okay, by some distance, if we are calculating this E1, its value is given by E, that is the total voltage, C2 upon C1 plus C2. Okay, how it is coming E by 2? You can see from here, C1 and C2 are equal. You can see from this equation. So it will be E C2 upon 2 C2 we can write. C2 and C2 cancel, so it is equals to E by 2. Similarly, E2, it is E C1 upon C1 plus C2. We can write it as E C1 upon 2C1, which is also E by 2. So E1 and E2 both are coming out to be E by 2. And when we are getting its difference, it is equal to 0. Now comes the second case, when the movable plate is moved by a distance x. A displacement x is applied to it, so the distance is decreased. For the first capacitor, it will be d minus x, the distance between the plates, and for second capacitor, the distance between the plates is increased, that is d plus x. So for in that case, C1 will become epsilon A upon d minus x, and for C2 it will become epsilon A upon d plus x. Okay. Now let's calculate the E1 and E2. E1 is calculated by E C2 upon C1 plus C2. Putting the value of C1 and C2 here, C2 is epsilon A upon d plus x, and here we are having C1, which is epsilon A upon d minus x plus epsilon A upon d plus x. Okay, so from here we will get the value of E1 as d plus x upon 2d E. Epsilon A, they will be cancelled, and here we are having d minus x, d plus x, so x and x will be cancelled. We are left with 2d. Okay, and here we are having d plus x E upon 2d. Similarly, E2, it is E C1 upon C1 plus C2. Putting value of C1 and C2 in this equation, E epsilon A upon d minus x so when we solve this, we will get the value of E2 as d minus x E upon 2d. Now if we calculate the differential voltage, which is the difference between the E2 and the E1, so E2 minus E1 will be E2, we have calculated d minus x epsilon upon 2d minus d plus x E upon 2d. So when we solve this, E2 minus E1 will come out to be x E upon d. So from this equation, you can see that the output voltage or the differential output voltage is directly proportional to the displacement x. So we can say that output voltage and displacement, they are linearly related, and how you can see that displacement is causing the change in the capacitance due to change in the distance between the plates, and how this displacement is being converted into a differential output voltage. So the magnitude of the output voltage will be equal to the magnitude of the displacement applied to the movable plate. So in this way, the capacitive transducer, it can be used for the measurement of displacement by causing the change in the capacitance due to the change in the distance between plates. So here in this video, we studied about the capacitive transducer. We saw various types of capacitive transducers. First, where you saw that how it is used for the measurement of linear displacement, then rotational displacement, then for the pressure measurement, and then we see that how displacement is measured by converting it into a output voltage. So all these capacitive transducers, they are using the principle of change in capacitance due to the change in the distance between the plates. So I hope that this topic is now clear to you. Thank you.